Hello everyone, welcome to another video of maths problem solving. Today we're going to be doing a question from an Olympiad. So it's the Hamilton Olympiad from 2020 and it's a geometry question. So yeah, let's get into it. The diagram shows two semicircles, as you can see, and the relationship between the two of them is that the point C is the midpoint of ED, and there is a rectangle which is inscribed within. Okay, so let's just start by labeling some sides, as we should always do with geometry questions. So we can label this as R, the larger semicircle's radius, and maybe let's label CD as X for now. And we also know that ED is double of CD. Therefore, EC plus ED equals ED, which means EC also equals X. So now let's just write this. So EO is the radius of the larger semicircle as well, which basically equals 2x, because it equals EC plus ED, plus OD, which is the smaller semicircle's radius. We'll just label maybe OD as A for now, A being the smaller semicircle's radius. So I guess I can just rub this out and label it as A. Okay, so OA also equals A, and now AB, so let's just consider this for now. AB equals the same as CO because it's a rectangle. Therefore, AB would equal to X plus A. Therefore, let's just consider OAB for now. So the smaller side length is A. This is A plus X. And now the hypotenuse is going to be R. Therefore, due to Pythagoras' theorem, we can now label this as so. A plus X all squared plus A squared equals R squared. Okay, so now we have one relationship between R squared, which is the larger semicircle's radius, and the smaller semicircle's radius. Now the next relationship which we can maybe derive is that is this one over here. EO equals 2x plus A. So let's just rewrite this as R equals 2x plus A. And yeah, we basically just need to work through the algebra now. So then we can label R squared as 2x plus A all squared. So now both of these are written as R squared. So then we basically just need to solve through this equation. AX all squared plus A squared, I'm taking this particular equation over here, is the same as 2x plus A all squared. Now let's just work through this. So A squared plus 2AX plus X squared, just expanding out that first quadratic, plus A squared equals, now let's expand the second one out, 4x squared plus 2ab, because that's how you expand quadratics, so that is 4ax plus a squared. And yeah, let's just collect the like terms. 2ax plus x squared plus 2a squared equals 4x squared plus 4ax plus a squared. And now let's subtract a squared from both sides, so we just get left with a squared. Now let's subtract 4x squared from both sides, so we get minus 3x squared. And now let's subtract 4ax from both sides, so we get minus 2ax. All of that equals 0. And now if we just rewrite this like this, multiplying everything by minus 1, we basically just have a quadratic which needs to be solved. That should not be a plus, that should be a minus. A squared equals 0. So yeah, we just need to solve through this quadratic. So by the AC method, we know that the product must be minus 3, because 3 times minus 1, and the sum must be plus 2. Therefore, the two things are probably going to be plus 3ax, minus ax, and minus a squared. And now we can just factorize this. So 3x factorizes like so, plus just a minus a x plus a, which equals 0. Therefore 3x minus a x plus a equals 0. Okay, this is quite good. Well, now we have two possible relationships between x and a. So either 3x equals a, or x equals minus a. Now both x and a are side lengths, so this has to be wrong basically. So therefore 3x must equal a. Now this is quite useful. If we go all the way back to our original diagram, 3x equals a, and a is the radius of the smaller semicircle. Therefore, if we just write the area of the smaller semicircle, that basically equals 3x, which is the radius, squared times pi. And now the area of the larger one, is just 5x all squared times pi. Now, okay, here's a bit of a shortcut. So we know that the ratio between the side lengths of the two semicircles is 3x to 5x, right? Therefore, we know that the area scale factor must be in proportion to this. So 3x squared to 5x squared must be the area scale factor ratio. So therefore, we don't really need to expand out these terms. We just know that the ratio is going to be 9 to 25. Okay, so yeah, that's basically our final answer. 9 to 25 is the ratio. Okay, yeah, so now So yeah, thank you for listening to the video. I hope you enjoyed it and hopefully you learned something new. If you enjoyed it, please be sure to leave a like and subscribe. And I hope to see you next time. Thank you. Bye.